So hello everyone, we are here, we are having the question with ourselves. What it is saying that the eccentricity of the ellipse. Supposingly if you have given the equation of the ellipse, now it is asking the eccentricity for this ellipse. Okay, so we are familiar with the standard equation of the ellipse. What it is basically that standard equation of ellipse in this format is x square upon a square plus y square upon b square is equal to 1. So this is basically the standard equation of the ellipse, but what it is given over here, this is not a standard, this is the expanded form which is present in x square. Coefficient of x square is also present and coefficient of y square is also present, and y, all those things are present. Okay, so but we just want to give the equation in this format. So what we need to do is to just make this equation in this format. Okay, so that's what we are just going to do over here. So I'm just writing 9x square plus 5y square minus 13y is equal to 0 over here. So let's take this over here, 9x square. Only I'm just taking 9x square over here. Okay, but what we are just seeing that this is basically having something, that means we could actually derive something from here. If we are just taking 5 common from here, then what I'm just going to get is that I'm going to get y square minus 6y. Okay, this is what I'm just going to get. Okay, so this is basically 9x square plus 5. Now I just need to make this into something like, I just want to make this whole, that means y square only. This is now for now it is y square minus 6y, that means they just divided, but I just want one thing only for this. So what I will be doing is that y square minus 6y, if I just add a plus 9 and minus 9 over here, the equation is not going to be affected for any matter. And what I'm just going to do is that 9x square plus 5 of y square minus of 3y over here, and then minus of 3y plus 9 over here, and just 5 and 9 will multiply and just get out of it, which is 9 5 45. So what I'm just going to get over here is that by taking y common over here, y minus 3 again over here, and what was over here, y. Okay, so minus 3, then y minus 3 again I'm just going to get, and then 45 would go in that side. So 9x square plus 5, I'm just getting y minus 3 whole square, and for that reason I was just trying to make this into that only. Okay, so now I get this equation with myself. Now what I need to do is I just want to make 1 over here, and here 45 is present, just let's divide whole equation by 45. So what I would get, 9x square upon 45 plus 5 y minus 3 whole square upon 45 is equal to 1. So what I'm just going to get is basically 9 and 5 over here, so x square upon 5 plus y minus 3 whole square upon 9 is equal to 1. So this is the standard equation I just got by solving this equation. Okay, but what I just need to find is over here is basically the eccentricity. I'm having the value of a square is equal to 5 and b square is equal to 9, but I just need to find the eccentricity, and I know the relation between the b square, a square and e. Okay, so 1 minus e square over here, so b square is basically 9 and a square is basically 5, 1 minus of e square. Okay, so just let's solve this equation. So let's see what we are getting. We will be getting 5 minus 5 e square, so 5 e square would be basically coming out to be, but we are able to see that this is basically smaller and this is basically greater. Okay, so this is basically going out to be what we are going out to be, what it is basically, that b square is going to be 5 and a square is going to be 9. So just replace it over here, a square is coming out to be 9 and b square is coming out to be 5 over here. So let's put 5 over here, and then 9 minus 9 e square, 9 e square again over here. So what we are getting is that 9 minus 5 is 4, that means e is getting 2 by 3. That means we are having the value of eccentricity is basically 2 by 3. So let's match with the option. So we are having the second option is just matching with this. So this is basically the solution for the whole problem, where we just need to find the eccentricity for the ellipse. Thanks for this video. Later we'll be seeing in another part.